So, hello everyone. Today we are going to solve LeetCode problem number 3208. The problem is marked medium on LeetCode, and the problem title is alternating groups 2. And the problem statement is that there is a circle of red and blue tiles. Okay, this is the circle you can see of red and blue tiles. You are given an array of integers, colors, and an integer k. The color of tile I is represented by colors of I. You can see the color of tile 0 is represented by this 0, color of tile 1 is represented by 1, and tile 2 represented by 0. If colors of I equals to 0 means that tile I is red. In here the 0th tile is 0, so this is red, and the one tile is having the value 1, so this is my blue tile. An alternating group is every k contiguous tiles in the circle with alternating colors. An alternating group. This is, you have to understand. An alternating group is every k contiguous tiles in the circle with alternating colors. Okay, so here one alternating group may be this from starting k. Suppose k equal to 3, so this is the alternating group, right? This is the alternating group. Why? Because it is 1 0 and it is 1, it is 0. The colors are alternating. This is red, blue, red. This is an alternating group. What would be the next alternating group? The next alternating group would be this, starting from 1 1 0 1. This could be my next alternating group, and my next alternating group could be this, starting from this 0 0 1 0, this one. Next my alternating group could be this, starting from 1 0 0. Next alternating group can be this, starting from 0 0. No, this cannot be my alternating group, and in the previous one 2 was not my alternating group. Why? Because you can see in this alternating group 1 0 0 0 0, these are not alternating, so this cannot be my alternating group. This cannot be my alternating group that was starting from 1 0 0. Similarly, if it is starting from 0 0 0 1, these two cannot be my alternating group. So these 1 2 1 2 3, these three are my alternating groups here. So this is the meaning of this statement. Next, return the number of alternating groups. Note that since colors represents a circle, the first and last tiles are considered to be next to each other, right? In this example, suppose this is array. The first tile and the last tile are next to each other. So this is basically a circular array. So to represent this array, this is the visual representation of the array. I have here created this to better understand it in a better way. So first you are from 0, you are checking these three, right? You are checking these three if this is alternating or not. Next, what are you doing? Next, you are checking for this one. Next, you are checking for this group. Next, what are you doing? Next, we are checking for this group. Next, we are checking for this two and this one, right? Next, we are checking for this one and this two. So we have to check this one and this two. In order to make it easy, what we'll do is we'll append these two at the end of these colors, so that we can access these two elements without going out of bound of the array. So what we will do is, if there are three and the group size is 3, so we are appending two elements from the starting at the end of the array. So if there are k elements, so then we would have append k minus 1 elements from the starting at the end of the array. So what we will do is we will update the colors colors array. Colors will now contain 0, 1, 0, 1, 0, again 0, 1. This one. Now you can see if k equal to 3. So this is one array. So my result, let me write here the result or output, you can say result. So this is one group, right? This is one alternating group because every other color is alternating. So this is one group. So in my answer I will add 1 plus. Next, what is the next group? The next group is this one. The next group is this one. This is also an alternating, so I will add one more in my result. Okay, let me add 1 plus. Next, what is my next alternating group? Or did it go? Next, this is my alternating group, and then I will add one more here. Next, this is my alternating group. You can see this is not my alternating group. Why? Because these are two equal, they are not alternate. That's why I will not add one. Now I will check this one. This one too is not alternating because 0, 0 is same. It is not alternate. So this is my answer, 1 plus 1 plus 1, which is equal to 3. So my answer will be 3. You can see the answer is 3 here. So let's come to the approach. How can we solve this? So I think you have understood this, that why I have appended these two. In order to make this array circular array, I have appended these two. So this is the representation of this one, right? Let me, okay, this one. This array represents this circle. In order to make the array circular, we have appended first two elements at the last, or you can say first k minus 1 elements at the last. So what would be my brute force approach? The first approach can be check for every group. Like this is a group, check this group is alternating. Next, check this group is alternating. Next, check this group is alternating. Check every possible group if it is alternating. So how can we do that? Create a for loop that will run from 0 to n minus k, because there are a k length group, so n minus k. Now check for j equal to I plus 1, right? If I it is 0, if I is 0, then j will start from here and here. And if for j equal to I plus 1, 2, j minus I plus 1 should be less than equal to k, right? Check for k length, j will my run. I will start from here and j will start from here, and check if it is equal to 3. When j reaches here, let me write, I starts from here, and j starts from here. So when j will come here, its length will be 3, that means equal to k. Then check if it is alternating, right? So I will write here, if my current I can say array, if my current substring, I can say substring, not sub array, if my current subarray is alternating, then I have to answer plus plus, right? If it is not subarray, then go to the next subarray, then again go to the next subarray. So this is how you can apply the brute force approach. And the time complexity will definitely, that what will be the time complexity here? If I talk about the time complexity would be this is very easy. The time complexity will be big O of n multiplied by k, right? K is the length of the every alternating subgroup. The time complexity is big O of n into k, so this will give TLE. So let me code this approach. Let me erase this first so that I can show you from the scratch. Okay, this will definitely give TLE. Let me code the brute force approach. So the brute force approach is, first what do I have to do? Update my colors array to make it circular, right? To make it circular. How can I update this? Like for int I equal to 0, I will create a loop and I should be less than k minus 1, right? I have to update my first k minus 1 elements at the end of the array. I plus plus and scalars pushback. I'll push back my 0 rs colors of I, right? I'll push back. So I have updated my colors array. Now let's go to the brute force approach. The brute force approach was for int I equal to 0. I will start from 0. I should be less than equal to n minus k and I will be plus plus. So I have to declare my size variable int n equal to colors dot size. Now create another for loop for int j equal to I plus 1, which will start from j equal to I plus 1, and j minus I. Run it until the length of the subgroup becomes 3 or equal to k. J minus I plus 1 is less than equal to k, and I will be plus plus. Sorry, j will be plus plus, right? So check if my colors of j is equal to colors of j minus 1. That means if my subgroup, if the current subgroup is alternating, right? If the current subgroup is not alternating, sorry, because the adjacent elements are equal, so it cannot be alternating, right? Then you have to do this. Let me create this arrays brackets. So here take a boolean variable called is alternating equal to, first initialize it with true variable. Assume that every group is your alternating group. So if colors of j is equal to the previous element, then it cannot be alternating. So update is alternating equal to false. It cannot be alternating, right? And break the loop from here. Now next, if it is alternating, now at the end of the while you are done checking the current group, then check if it is alternating. If it is alternating, then update your answer as plus plus, right? Update the answer plus plus, and at the end return the answer. ANSW, return the answer. So let's run this. This should be able to pass all the example test cases. Okay, is alternating. Undeclared identifier is alternating. Where is alternating. Okay, where I have declared this. Okay, I have declared it in the wrong loop. Sorry, I have to declare it here because the group is starting from here from this loop. So at the first I have to assume that this group is alternating, and if it is equal to this, then the group is not alternating, so I have to initialize this as false. So now this should be able to pass the example test cases. Okay, okay, I have not declared the answer variable, so I have to declare here the answer variable. INSWER answer will be equal to 0. Now let's run this. Now this should be able to pass. Yes. Now let's try to submit this now. I have said previous that this will not pass every test case because this will give TLE, that is time limit exceeded. Okay, because here the time complexity, I've already shown the time complexity is big of n multiplied by k, right? So let's optimize this. So how can we optimize this? This is the we can optimize this using sliding window approach. So what were we doing previously? Let me copy this one first. Copy. Where is this? Okay, I have to write. Okay, so this is my colors array after updating 0, 1, 0, 1, 0, 0, 1. So this is my colors array. And what was I doing? See it carefully. This was my subgroup of length k, that is 3. Now we are checking that if it is alternating. We have checked it. Now we are checking for this one, right? We are checking for this one. If it is alternating, yes, this is alternating, so answer will be my 2. Now check for this one. Is this alternating? Yes, this is alternating, so answer is 3. Now check for this one. Is this alternating? No, because 0, 0, and they are not alternating. Now check for this one. Is it alternating? No, because 0, 0 is there. So this cannot be alternating. So my answer is 3. So sliding window, using sliding window you can solve this, right? So while we are checking for this window, I was starting from here, and J is here, right? At the end of this window, J will be here. So when I am sliding this window towards right, so I will just update my J, right? I will just update my J. I just have to update my J, and I just have to update my I. Okay, sorry. I just have to update my I. So if I update my I and if I update my J, then the problem can be solved in big O of n time, right? So next I will be here, and the window, this window I will check, and I will update my J as well, and I will update my I as well, and I will update my I as well. I will be here, and this will be here. So like this I will go at the end of this window, like this one. J will be here, and at the end I will be here, right? And my answer will be 3. So this is how you can we can solve this using sliding window. So let's write the code directly. I will not write the pseudo code here. Let's write the code here directly. So this will be same. Update the colors array. Let me erase this brute force technique. Right. This will be same. First update the colors array to make it circular. Then n equal to colors dot set and initialize answer variable. Now initialize two more variables, int I equal to 0 and int j equal to 1, right? Next, create a while loop. While my j is less than n, you have to check if colors of j is equal to colors of j minus 1. That is, if the, let me full screen it, maximize it. If that means if the uh, current group is not alternating, then you have to do this. Okay, if it is not alternating, then update the I variable. To j. Take I to at the position of j, and at the end if and at the end if j minus I plus 1, that is the length of the sub array or the current group is becomes equal to k. And if the length of the current group becomes equal to k, then you can update the answer as plus plus, and you have to update the I as well, because you are going to the next window. In order to go to the next window, you have to update the I, and at the end update j will go on. Now this is now let's run this. I think this should be able to pass all the example test cases. Yes, it has passed all the example test cases. Now let's try to submit this, and this will be submitted. I think, yeah, this is submitted. So let's talk about the time complexity. So what is the time complexity here? You are just there is one loop, while loop, and it is going from 1 to n. So the time complexity is simple, very simple. The time complexity will be big of what? Big of n. The time complexity is big O of n, right? N means capital N, which is the updated size, because you have updated the colors array. So this n is the capital N. In the previous one, this n was this was to the capital N, the updated size, right? So this is how you can solve this.